Hello guys and welcome to another video about navigation 3, and in this one we will be covering deep links. Pretty straightforward and honestly boring task. This is actually my second um, attempt to filming this. I filmed the alternative approach that I will show you at the end of the video, so that will be a homework for you. But I decided to not post that one. Instead, I will re-record this as a standard way of dealing with deep links and uh, yeah, pretty standard procedure. So we can jump straight into the code. We will do, as you can see, we have parse deep links test, and for later we have homework. We will cover what are deep links, how we will use them, and how is it different in navigation 3. So what are deep links? Those are basically URLs that send users instead of, when you click on the URL, it will send you to a website. Deep links for the app send you to the app, and your app needs to know how to handle those URLs. So you can have user directly going deep into the fourth screen of the app, skipping the first three if they have a correct link. You probably know all of that already, but that's the basics of it. In this video, I will not be showing you how to set up deep links because that's outside of navigation 3 library, but it is pretty straightforward and there are a lot of tutorials online about it, but I could not find one about this. So that's why I'm filming it, and we will see this standard procedure of parsing and dealing with deep links. We will see how we will build our backstack depending on what we parse from those URLs. I will give you a lot of ideas how you can handle this based on how your app looks like and behaves. So we will have a little brainstorming session instead of me going and implementing this in four different ways. And I will show you the homework, the alternative way that you can play around with. It worked great for me, but there is one trade-off to it, and I will mention it when we come to it at the end of this video. We will do this TDD style, so let's just write our first test. I like to write this nothing thing and just see if we can run things. Yeah, we can run things. If it will fail, just to see if our setup is working correctly. Yes, it does. Okay, nice. So first, what we need to do, standard TDD procedure, smallest steps. So we would need to be able to call the actual function first. So uh, I don't know if this should be capital or, but we will keep it like this. For the simplicity's sake, I will put it above the test class, so it will be pretty visible. If it grows and becomes unwieldy, then we will split it, left and right on the screen. But for now, let's have it like this. If we run the app now, it will pass, and we will have to do because we want failing test for the next one. Yeah, it fails. Now it passes refactoring. We don't have to refactor anything. Let's move on. Okay, small interruption. Let's move on. So we need to pass something in order to get something out, and we will play this thing of golf, the smallest amount of code to pass. So we need something to go in. So for the null and something to go out. For now URL return null. Well, we don't need to do that. No. Parse the deep link. Null. So now we need to change the signature of it. URL. It would be the type of string. And here we have this, and it will need to return something, and it will return one of our screens. We can already put it here, and we will name return no screen. We can already do that because we know that we want to get some of our screens out of this. If we run this, we will get we will get failures, and we will just return the URL. Return? No, I don't want to return the URL, but we will return. No, okay. Then we go to another one. So for empty URL, it will also return no. Yeah, we are flying through these. The next test case, now we will probably need to do something a bit more intelligent. Now, our next test case, now we will return, this starts to grow, unwieldy, and you cannot see everything, so we will do this instead. We can run the test to confirm that everything runs nicely still, and it does. Nice. So right now we will need to do something remotely intelligible, and we will need to parse some URL for the actual screen. In our use case, it will not make sense to write on deep link for the onboarding one, since it is already defined as the initial screen. And if you remember, you have to have an initial screen. So for the sake of the example, we will write the test for onboarding 4. We will just jump to onboarding 4. So we will have a test, parse onboarding for deep link, and our URL will look something like HTTPS. It's fine. Onboarding 4. Assert equals onboarding 4. It gave me the wrong one. Yeah, onboarding 4. Parts and URL, and we'll run the test. Okay, it will be back in a minute. This one will of course fail, and if we return on onboarding 4, then that one will pass, but the other ones will fail, which is expected. So we will do return if URL is null or blank. No, else do this. Standard TDD practice, yes, it is stupid as you go, but it falls into place very nicely. At this point, we have things to clear up. For example, this was just a staircase test. We don't need it anymore. We can delete it, and we will see that everything runs pretty nicely. We can have this as an expression body, and we can format this a bit differently. Okay, so that's it for this one. Now, I should have explained. So your registered URLs for deep links have to have a structure, and this is the structure that I chose just for this example. But your deep links URL structures need to be tied to some specific URL structure. So you cannot have if you register example.com, you cannot have a.com. So that's why I'm doing it like this. That shows a convenient example for unit test. Now let's go and write a unit test for some of our other screens. For example, onboarding 2 and 3. They have parameters, and we will start with those. We'll start with onboarding 2, and for start, of course, we're doing this TDD way. We will do it without the name parameter. We'll just pass an empty string. But let's write test for this one. So pass onboarding to 42 to onboarding to to the autocomplete is running wild. Okay, just an empty string. Why this is not? That's why it has to be a screen. Of course, now when we run this, it will fail. Expected onboarding 2, got onboarding 4. Okay. As I said, something remotely intelligible. We will turn this into a block body, and we will uh, have this return here. And then before that, I skipped one important step that I always forget to do, but it's important when you're doing TDD to make sure you did not broke anything. So we will ignore this one, do the refactoring, and then let's see if our previous tests work still. They do, refactoring worked, and now we can jump to this one. Okay, fails for the same reason, expected 2, got 4. Okay, uh, then the URLs have structure, and we'll first construct the URL. We will use ktor URL for this one, depending on the library that you're using, but they're all the same, really. This okay, URL dot encoded path, just so you can see where we are heading with this. Okay, but this is what it got out of it. Okay, so the encoded path is the onboarding 2 for the past one. For this is the onboarding 4. So it is this path, and then we are doing TDD, so this will be very stupid, and we will refactor this afterwards. So when onboarding 2, because 2 comes before 4, if you didn't know, onboarding 2, on onboarding 4, let's run it. Oh, yeah, else to be done to do. Okay, so now everything is passing. We will deal with this parameter just a bit later. First, I want to clear this up because although this is pretty valid thing to do, I don't like this, and it will complicate things down the road when we started to extract parameters. For example, on our onboarding to screen, it expects name, so we will, you know, we'll need to have a parameter name, for example, something like this, and that when statement will start to become very, very unwieldy. So now we will do uh, refactoring. Let's see here, we can do some nice refactoring here. Okay, and now we will split those those into separate parsers. We'll have parse deep link as the controller for the whole thing. It will do like check for the not null, etc. It will do all the common stuff, but we will extract and have a parser for every single one of these screens, and then we will collect them into a list and just return whatever was parsed. Or else we can do null here, and let's see if there's, of course, this will pass. We have another refactor to do first because comparing encoded paths is not a great idea because let's go this showcase. You have to be registered for the exact domain, but if you are not registered for this domain, this test will pass. and it should not be passing. It should fail. So we will it we will write a test for it for now. This will probably be probably be a staircase test, but maybe we will leave it in here. Yeah, it's failing as it should be. Okay, and we will have rejects. Uh, for is not that one. We'll have onboarding 2 projects, and then we will have onboarding 4 projects, and then those will be this, and when we will do when onboarding 2, we'll do this first. Matches our input. We'll do the same for onboarding 4. Matches our input. But why is this not? This is still completed successfully. Will not complete successfully anymore. As I said, well, with the edge case, with this edge case later. But you see that already this grows unwieldy. But we don't need to do this. Afterwards, we will just throw illegal argument exception, unsupported deep link, URL. I would do this using arrow to return an either and all of that, but I will not bore you with that. Not everyone is into it. Okay, so this will not remain a staircase test. This will stay here. Not this one, this one. But then we need to rename it. Mm. Fails for non-registered deep link URLs. Mm-hmm. Yes, I can spell correctly. And now we will slowly start and extract this. So we will have private fun, parse onboarding to deep link with a URL, and it will return. We can return onboarding, nullable onboarding too, but let's just return screen. And in this case, it will never be null because it cannot pass this check. Then we will have this one, and if onboarding to matches our URL, return. Yes, onboarding to onboarding to with an empty name. Else, no, like we can format it that way. Okay, and then we will do the same thing for this one. For a list of return first, not null of Mhm. So our every single one will look exactly the same. We can do some refactoring there. You can have objects there. You can have classes there. You can have whatever you want in there. But I like to keep it, just as a simple function. There is no need to introduce interfaces, classes, whatever. As you can see here in the type hint, every single function has a signature, same as an interface. So it is the same thing. You can maybe change this. We can inject it or do whatever. But for now, we will leave it as it is because let's be honest, this parse deep links, this needs to be somewhat of a closed system with the support of with the support for other for other for all screens. So I'm thinking about renaming this. I just noticed the typo. Okay, now we will write a test so that this will not return onboarding with an empty string, but with the actual string that we are passing, and it cannot be now parse onboarding deep link. Yeah. Let's have it onboarding deep link with name. Uh, with name. It can be parameter, it can be whatever. So name will be you. It will of course fail. There is one thing that you need to know about regex, and the only thing that you, for this example, that you need to know about the regex is are groups. So this is how you define a group. So it will match um, everything that comes after this. It will be in a group. I will show you what I mean. So we will have result onboarding to dot find in our URL, and then we have it will find it. We already know that, so we can bang it. So result dot group values for each string. We will do string dot s out, and we will run this. It will be this. This will fail anyways. Pass onboarding for y onboarding for through an exception. Maybe because this came before it. Mhm. But you can see that we have u as matched value for our parameter. I just need to figure out why this one failed. Mm-hmm. Null pointer exception. Very helpful text message. Yes, okay, it failed here because it will not match, but okay. It was just for me to showcase to you the groups again. Oh yeah, this one should be failing. Okay. Um, and then we will do again result. We will do onboarding to regex dot find in our URL, and otherwise we will return null. So now we are safe. Nothing will fail if this one fails. Just the one that requires us to have the actual name. The first matching group will be the whole URL that was passed, URL that will look like this, and the second one that we need, the name, will be what we need. So we will return onboarding to with name. It's a result group values of one name, and that one passes too because again I'll just showcase to you very quickly. This one will be This one I will fail it just so it stops there. This one will be the whole thing. As you can see, this one is the whole thing. We don't need the null, the zeroth one. We need the first one. It is the name. If this starts growing somehow, for some reason, because for onboarding three we have name, first name and the last name. Then you will have again you will have this, and then this will be the name, and this would be the last name. But for now, we don't need it. Let's revert our changes, run tests again, and see that everything is passing again. With that out of the way, now we can start thinking about more complex scenarios, like, for example, like building a list of uh, screens that lead to this screen that was deep linked to. For example, our onboarding tree. How, if you were following the series, you know how this works. But if you didn't, we have onboarding one where user enters the name. Then we have onboarding two when user gets the name entered on onboarding one. On onboarding two screen, user will enter the last name. Then we will, from the name and the last name, we will form full name, as you can see here. And then we go onboarding three with a full name, but that requires a list of steps. So we need onboarding one, onboarding two, and onboarding three. If we will deep link to onboarding three, then we need to build a backstack to it. When we go back, we would need to be able to go back from three to two to one, and those should be populated with last name, with the first name that was entered in a deep link for onboarding three. So now we will solve that problem. But how we will do that? For start, we will be, instead of returning a single screen, in this case, it will be just onboarding three, our initial screen onboarding one, and then onboarding three. We need other screens, so it will be a list of screens, and all of these will return a list of screens. So a list of nullable screens. Well, they don't have to be null right now. They just need to be a list because the list can be empty, which is same as null, doesn't have a value. If I can type, okay, and then we will need to refactor this, return um, return list of not null. No, let's not be smart. Uh, hmm, we will return empty list if this is here also empty list, and here it will be a list of, and here it will be empty list. We need to change this one. Parse. Okay. List of. Okay, here it will be empty list. You know the type, don't empty list. Okay, and then we will rerun the tests and see if those will pass now. They don't. Let's see why and which ones. Okay. Parse onboarding 4. Deep link expected. Okay. So all of this empty list complicates things a bit. So we will return, be returning null when we don't have a value, just so we don't have to go through lists and then check for if there is an empty one, and if there is an empty one, then we fail. Okay, so then it will be parsers. We will need to run a map. We invoke every single one of these, so it will do this, and it will accumulate the list of lists that everything returns, and then first, the same as before, first not null of it, and then we have everything passing. These two are not because they're not named properly. And to be honest, from this one, I would return uh, non-empty list. So let's see. It all depends on the use case. As we said, we'll just rename those for return empty list, return empty list. Okay, so now we have steps ready to implement onboarding 3 and the list of screens that will lead to it. Let's get to it. We'll copy paste this one, onboarding 3, parse onboarding 3 deep link, parsing deep link returns list of onboarding 1 and onboarding 2. First, we will test them without the appropriate names, and then we'll add tests for 4 names. So onboarding 3, then yes, we expect that one. Separate. So it will be onboarding 3. We will just, for now, assert equals 3 parse URL size, and then we will, this will be full name, full name. If you run this, of course, this will fail. No elements. Of course, there are no elements. We don't have it. Onboarding 3, onboarding 3. Now it will be the exact same. Well, actually, we can do this and then change things around. So onboarding 3, onboarding 3, return a list of onboarding 1, onboarding 2, and onboarding 3 with the same name. As we said, we are not testing for that right now. That will be a separate test, and we need to edit to add that one here. Okay. Now we will write a test for this returning the appropriate values, screens with appropriate values. Returns parsing 1.3 deep link, returns on onboarding 3 with correct name. It will be the last in the list, and we will have onboarding 3 with full name. Let's see if this is passing. Yes. Okay, then let's write parse onboarding 3 returns onboarding 2 with the correct full name. Here will be with the correct name, and we will deconstruct this. It will be name, last name will be the last name, and full name will be name and last name. I like to format my function. I will do that for the others too, but now let's do this. It will be just the last name. Import two. Let's see. This one should fail, as it does because it returns a full name. It expects the last name, but it gets a name, the last name, so it gets the full name. Where is it? It's here. Okay. Now, again, this can differ. We can have the onboarding tree be passed like this. Then we will have more groups. The first name will be this one. The last name will be this one. For our example, we will just have them as as a single string. And then what we will do is we will have first name, last name, and we will assume that it will be like this, and it will be a last name, and here it will be first name and last name. Let's see. Okay, that one works. Two, and let me just do this. Well, I will not do this. Those are pretty small and readable. Those ones are a bit bigger, and they need the separation of a setup, action, and then assertion. Okay. Well, that pretty much covers it. For the Warriors case, I gave you all the examples that you would need uh, for this one, and then we will have now we will see how to implement this, and then we will have a discussion about different use cases for deep links, because not every app is created equal, and every app that I worked on had different deep link structures and things that it needed to do. So it's not a cookie cutter solution. There is no cutter solution for this one. This is just the most basic part of doing that, and then we will speak about this homework that I mentioned in the beginning. It's time to test what we done. Let's have the link back stack as a list of screens. We can see that runtime checker. I'll not mark it as immutable. Who cares? The deep link back stack, and then we will have uh, add all. We will have this so it doesn't fuck up our iOS. I will test this just on Android because it works the same. So here I commented out all the Android one because we have all the same names. I've created the backstack so we can test if it will work. So let's see, first try. Yes. So step 3, step 2, step 1, and without it, if we don't have a backstack, then just step 1. If we do have our backstack, then we have step 3, step 2, step 1. Now, how I artificially built this backstack, but how that would actually work is you will get your deep link will be this data URI. So this is URI, and you also have data string, which is a string of that URI, and that will be your URL, and you will call parse fine, I guess, and we will use some of our. We will actually use this one test instead of getting this intent. We will have URL. It will be okay. Then we will inline this. we will pass this URL here, then we will have this here. We don't need this anymore, and let's run it. Okay, so it's step 3, full name, as we have here. Okay, hello main. Okay, that's all good. You will of course not get this. You will get encode URL. When you get it, just decode it. That's it. But that's it for our example. That we have this. This may be weird for some apps. For this one, it definitely is. So what we can improve for our use case here is for the deep link, parse deep link to not return empty list, but if it cannot find anything, etc., it will just return onboarding one. It will return a list of onboarding one, and then we will have this always. It will always try to parse the deep link, and then it will have it will be like this. I mean, let's just try to one-shot this and see what happens. Yes, it goes to step 3, 2, 1. It crashes because it can be empty, but we covered that already in previous videos. So you see how much flexibility you need and how much flexibility you can get out of this deep link parsing. This is standard way of how to do this. Does have regex. If you take a look at navigation 2 internals, this is exactly how they are doing this. If you take a look, I think everywhere, this is how they're doing this. But what I want to show you, and this is homework for you. I was testing things out here, but we can then remove this. Is to have wait, to have something like this, because we are using serialization library to serialize and deserialize our screens. And though serialization library has this descriptor, it describes how to serialize and deserialize things. So it has access to elements. Let's run and see what this one will print. But okay, so this is what it will print. So the first one, onboarding, it will just print encoded path. This is the encoded path. Parameters, we don't have any, but if we have param equals 2, then it will have parameters also. Let's just see. So you will have parameters also, and then we gather all the screens. So screen, serializer, descriptor, get. This is the descriptor for all of the subclasses of screen. We go through elements count, so through everything. We go to descriptor, we get the element of the correct iteration, and we just do lowercase. If we did not do this, we will get just okay, we will get all subclasses of our screen, as you can see. And if you then do this, if you then do this, you will get just the name of the subclass. It will be capital letters, but it is not common to have capital letters in URLs. So they'll do 2 lowercase, and then after that, what you will get is this, which is pretty common to get inside of a URL. I experimented with this. It works. It works well. I will leave this to you as homework, so you can try things out. The thing with this approach, it inverts responsibilities and dependencies. The first one with regex, external things dictate how your app will handle and what app will handle. This way, because we are running on the subclasses of our screen that we are defining in our app is defining what screens can it get. So if So the external things, like the things generating these URLs, have to adopt to the app. Again, depends on what you need, but this is the alternative way that flips responsibilities and dependencies. First one, external things dictate what the app can do and what it will do. This way, it is reverted. App dictates what external things can send to it and what it can deal with. Um, we can extract parameters, same as you saw we do with uh, with groups in regex. So we just have normal parameters. You can extract those, play with it if you want. This is just an alternative way how you can do things. You can very easily retrofit this approach into the one that we did. I basically gave you the full mechanism here. You just need to play around a bit. It's very easy. Just inverts the things. That is it regarding deep links. We have just one more video in this series, and that is about animations. That will be pretty quick and easy one, and then I want to switch to something which is much more exciting, that I like and love very much, and that is a circuit framework for building compose Android and Kotlin multi-platform apps. So I hope that you learned something from this, that this will be useful. See you in the next one for animations, and I'm very excited about the circuit series because we will cover a lot of cool topics. It will be about building pure compose apps, and it's a lot of fun, I promise you. So see you.